Hi, I'm Ashay. I'm an engineer by training and a storyteller by passion. I made this podcast to talk about data science, but no math, no equations, just intuitions behind data science. The episodes are not in any particular order, and you can just tune into any episode and listen to something related to data science. Let's get started. Let's get started. When we have data within a particular sample space in a population, we saw in earlier episodes we could do a couple of things with the data. We could either understand the behavior of the data within its sample space, or we could create some kind of correlation or a model between the attributes or variables of the data to understand the behavior of the data in some other sample space within the same population. So let's talk about that correlation or model approach where we want to predict the behavior of data in some other sample space to understand the intuition behind a loss function or a cost function. So um, in a particular data you would have, let's say, a dependent variable, and the dependent variable is a some kind of combination of different independent variables within the data. What you want to do is you want to create a model or a particular combination of these independent variables to predict the dependent variable in the data in your current sample space, and then use that model in some other sample space to predict the value of dependent variable in that sample space. Correct. So um, but understand this, that when you have a sample space you already have values of your dependent variable, and when you create a model from the independent variables and you calculate a value of the dependent variable, you basically have a predicted value and a real value of the dependent variable, and the difference between those two should be as minimum as possible. Basically the prediction of the value of dependent variable should be as close to its actual value within the sample space as possible. Only then your model is going to be a generalized model, and only then it can be used to predict the dependent variable in some other sample space. And the way to do that, to get the predicted dependent variable value as close to its actual value in your training data set in your sample space, is basically called minimizing the loss, or minimizing the cost. So why is it called loss? Is because if the difference is more, you are actually losing the credibility of your prediction. If the difference between the actual value of the dependent variable and the predicted value of dependent variable from your correlation, if the delta, if the difference is more, then you are losing the credibility of your prediction, or the prediction is actually costing you a lot. The closer the values get between the closer the values of actual value of dependent variable and the predicted value of dependent variable, the closer they are, the less is the loss, less is the cost to you. Now you will find many definitions of loss function, cost function, how they are related to each other, what is the relationship between them, and an error function. That's fine. The basic intuition behind this is you have a training set. You have your data set in your samples, in a sample space within a population. What you're trying to do is you're trying to find a correlation between independent variables to calculate a value of a dependent variable, and you want to use that correlation equation or a model in some other sample space to calculate value of the dependent variable in that sample space. And the way to know that your model is good enough to predict the dependent variable in some other sample space, you need to understand whether the calculated value of your dependent variable in your sample space is as close to its actual value in your sample space. And for this, always understand this, that you have to know the actual value of your dependent variable in the sample space. If you don't know that, then your model or your prediction is completely going to be arbitrary. And all the methods like gradient descent, stochastic gradient descent, all of these methods are basically to get the actual value of dependent variable as close to its predicted value of dependent variable. Thanks. Thanks for tuning in. I made this podcast to talk about intuitions behind data science, and we'll talk about some other idea in the next episode. There will be no math, no equations, just intuitions behind data science. See you soon.